Hello everyone. My name is Oren Voskin. I'm the Global Marketing Director at Sasa Software, and today in this session we'll talk about how Content Disarm and Reconstruction, or known as CDR, protects email messages, and specifically password-protected attachments in email messages. So a few words about our company. So Sasa Software and our GateScanner CDR technology is a proven and award-winning solution protecting over 180 enterprises worldwide with a global footprint in over 40 countries. We've been approved by IT security regulatory bodies, including in Israel and Singapore, and continually validated by independent tests. And we're the 2017 Frost & Sullivan ICT Security, so that's a critical infrastructure security vendor of the year for Asia Pacific. Cool. So what's CDR? CDR starts from a philosophy of what we call a world of zero trust. We understand that today's threats are highly sophisticated and evasive. So if you scanned a file with every technology available, AVs or with detection tools, are you sure that file is truly safe? We believe it's not. So Content Disarm and Reconstruction treats every incoming email and every incoming file as suspicious and disarms it. It transforms it into a new, neutralized, and a harmless copy that you can trust. And the key thing is to do this while maintaining full usability, visibility, and functionality of the file. And this way we prevent advanced, undetectable threats, including APTs, advanced persistent threats, ransomware, 0 days, and of course traditional viruses, and not only what's out now, but it's future ready against the future threats that today you cannot handle. Under the hood, what we do is a straightforward process. First of all, we take a complex file and deconstruct it. So we take a complex file and break it down into simpler elements. So for example, an email message that might have embedded pictures and the body of the mails, we scan not only the attachment, but everything included inside, break it apart and scan it separately. Then we scan the file with multiple powerful detection tools. So we have multiple commercial AV engines, multiple commercial TrueType engines. Some of them are our own technology to prevent file spoofing and file tampering. We also have a capability of running detection with advanced next-gen and machine learning scanning technologies. Then we understand that even this isn't enough. So understand that if we deconstruct the file, scan it with multiple tools, we dramatically increase detection rates, but that still doesn't prevent the undetectable. So we then have a set of disarm tools. First of all, to remove from the file anything that can potentially be harmful, such as scripts and macros and embedded elements, but even that isn't enough. So we'll restructure the file and doing changes into its internal structure to create a new copy that even if there was something, malware, deeply hidden and deeply encrypted or coded inside, it will break its integrity and will no longer be able to operate. We finally reconstruct, and now you have a file that's completely safe. Now, we understand that organizations have additional tools, so we can integrate with other technologies such as sandboxes, next-gen AVs, etc. Now, the mail route today is especially challenging. Over 70% of attacks originate from the mail. So we add Content Disarm and Reconstruction as a crucial layer of security between your secure mail relay that will do anti-spam, anti-phishing, and basic anti-malware checks. Run CDR process on the mail, again, on all components of the email message, not only the attachments, but on all components of the body, and then send the disarmed mail message to your Exchange server that can also be cloud-based, such as Office 365. Now, the challenge is with password-protected files. So users sometimes feel safe when adding a password to the file to protect their privacy. Now, it is possible to break that form of protection with the right tools and the right amount of time, but that isn't the real challenge here. The issue is that when you add a password to the file, it encrypts its content, maybe with a simple encryption, but it's encrypted. This prevents traditional AV technologies and traditional detection and scanning technologies from inspecting the file for threats. So you might receive a file from someone who you completely trust, a completely trustworthy file that you're expecting to receive, but you never know what happened at the origin. maybe that file or that endpoint was invariably compromised. So you'll be receiving an encrypted and secure file with a malware inside, with an attacker inside that can completely circumvent your security technologies. So what GateScanner does is it includes a mechanism for users to supply the password for the attachment so we can run our CDR on the file. And this is how it works. So the sender will protect the file. The user will then receive a notification that they received a password protected file, and that allows them to provide the password to GateScanner CDR. It will open the encryption on the file, disarm the file and disarm the attachments, create a safe copy, and then you can re-encrypt the file with the same key, and the user receives a safe file. So let's see how this works in real life with a real example. So I've got here an MS Office document. Let's open it up. Now I've added a password to it. And let's look inside what happens. So inside of the file, I've got an iCar embedded element. Now an iCar is just a string that's supposed to invoke every antivirus if it's scanned. So let's see if this indeed happens. We'll remove the protection. Save the file. And run it with my desktop AV and see what happens. All right, so my desktop AV indeed catch the iCar. Now I don't want to quarantine it since I want to use the file again for this demonstration. I'll open the file again. Add a password. Save it, and check it again with my AV. And it didn't find anything. Why? Because when I put the password, the file is now encrypted. But say, okay, so you say I might have the desktop AV isn't sufficient. Let's try it with something else. So I've got VirusTotal open. I will drag the file to VirusTotal. Uploading the file, and it's going to be scanned. So what VirusTotal does is scan the file with almost all the commercial AVs available. So it's testing now. I'm at 40 files, 50 AVs, and it's continuing its scan, 57. Scan the file with 59 AVs, some of them the leading commercial tools out there. None of them have been able to detect, and that's because of the password encryption on the file. So let's see what happens with GateScanner. And in case we forgot the password, here's a reminder.
Sir, we have the combination.
Great. What's the combination?
1, 2, 3, 4, 5.
1, 2, 3, 4, 5.
Yes.
That's amazing. I've got the same combination on my luggage.
Right. So besides using advanced detection technologies, I hope you're also using best practices with passwords, not like I did in this example. So I prepared an email message. Let's send the file to GateScanner and see what happens. All right, so I have here an Outlook client that will receive the message. And I've now received not the email message, but a notification that I've received a password-protected attachment. Let's open it. And I've got here a link to a secure web portal that I can provide the password with. Let's activate the link. Now opening a web browser to a secure portal. And I've received a request to supply the password to this file. I hope you remember the password from the video. Don't share it with anyone. And now I'll receive the attachment, the message with the attachment. Let's see what happens. Now, after I supplied the password, I received the original message from myself. Let's open it up and see what happens. So first of all, I see that I've got the entire message inside, the text, signatures, etc. But instead of receiving the attachment, I received an error notification that the file was removed. When looking at the log of the file, we'll see why. Looking at the log, I can see that GateScanner, after supplying the password, opening the encryption on the file, indeed detected that it had the virus inside. Now, that's a great example of CDR at work. But just remember that even if I deactivated the AVs completely and did not detect the iCar, then GateScanner would have still disarmed that file and prevented the threat. So even if this was a password-protected file with an extremely advanced attack inside, I still would have been safe. So summing it up, if I look at GateScanner mail, then we leave the basic anti-spam, anti-phishing, and basic anti-malware scanning to the secure mail relay. We provide increased detection rates because we deconstruct files and scan files of multiple technologies, including with capabilities of next-gen scans. We protect against unknown, so we have the capability of detecting the unknown with our machine learning capabilities and with connecting to external technologies such as dynamic analysis and sandbox. But our key strength is preventing undetectable threats by disarming the files. Now, if I look at some differentiators of GateScanner compared to other technologies, we focused on this session on how we protect password-protected files and password-protected attachments. So I hope you had